Hi, and thank you for coming. I'm Dan, and this is Norka. We're from Oracle Cloud Infrastructure, which is the next generation cloud that Oracle is building in the public cloud space. So we didn't check all the slides about what we're allowed to say, so we're just going to throw that up there and say, let's see what happens. To put some context on this, before we get into what we're talking about, a lot of today, or this week, has been about stuff that falls under sort of the SaaS or PaaS space. But we're building an IaaS product, which means that Norka and I live in the basement of the basic infrastructure. The joke that a cloud is someone else's computers, well, in this case, they're ours. And so we have to make this work. So to talk about, well, as a next generation cloud, we have this opportunity to figure out what we could do better. A bunch of us had worked on previous clouds and said, what would work there? And so when thinking about IaaS, we want to motivate where we went with identity, one of our changes, by starting with a basic cloud thing that if anyone has built a cloud service, this is the sort of the base case of you have a load balancer, some instances with a data store. But really, if you're building in the cloud, you should be doing a little bit more than that. So in this case, we've set up having a serverless system sending a test every couple of minutes to check your system. And then your object store, your database is rather backing itself up. And then for disaster recovery, you're backing up to a different region. So this is a very simple case. What motivates what we're going to talk about today is that there's just too much going on here, right? As soon as we start talking about this, we start saying, okay, well, our load balancer has to present itself as a certificate. We want to do MTLS between our load balancer and our instances because we're in this zero trust world, I guess. The database has to be talked to from the instances. So now we have to get them credentials. We have to have the database be able to back itself up to the object storage. We need the object storage to cross regional boundaries, which is another unit of isolation. So how do we manage all these things, right? The problem is there's just too many secrets. There's just too much going on. And if we're building these low-level things so we can compose them to be these greater things, we really want to have a framework for doing this. And so to go back to this slide, we want to talk about the better world that we're trying to talk about. So our system, and this is not, we're talking about this sort of as a pattern we want you all to pick up on. We do signed requests with this demonstration of proof of possession. Apparently this is a phrase. For all these signed requests between these services. And it's sort of a nicer, simpler world if we can have each of these things talk as if they were the things they were, because you can simplify your mental model of how your system works, how it authenticates and how it authorizes, if it actually is the things you think you're doing rather than the way it's composed. And so what Norka is now going to go through is the 4 patterns we found so far that have allowed us to describe all of the different types of services, from the base case of an object storage system to databases to Kubernetes and serverless systems. We can do these 4 patterns that have real-world analogs that help us understand how the infrastructure works. So with that.
Thank you, Nan. So let's go to our first pattern. Think about your birth certificate. Your birth certificate identifies you uniquely. And it was issued by the Vital Records Office of the state where you were born. So basically, what does that mean? It means that it was issued by a local authority, or let's say, of the infrastructure of society. So going back to our cloud scenario, the infrastructure knows what every piece of hardware is. And because it knows about it, it can attest to it by issuing a certificate. So that's what we call an infrastructure principle. So now, having a birth certificate, you can present it, let's say, to a federal authority to request a passport with the intention to travel abroad. So that means that we having already one identity, we can stack on top of another one to get another identity, and that's what the concept of a stack principle is. Basically, we project one principle into another. Our third pattern is the ephemeral principle. sometimes we have situations, okay, now I'm gonna go to the example first. Sorry. Today we're gonna have the conference party, right? And we're likely gonna get some drink tickets, or I hope we are going to get some drink tickets. So how do we get those drink tickets? Usually by presenting only our conference badge. And during the party, not necessarily having the conference badge or any other form of identity, we can exchange that ticket for a drink. So in this case, only the presence of this ticket is what allowed us to get a free drink. So basically, using injected identifiers as service, not the infrastructure, defines what a holder of a particular credential is. Because we're using ephemeral principles for situations where the hardware is decoupled from the infrastructure, such as in Kubernetes or Oracle functions. And our last pattern, the asserted principle. Now think about the situation where principal having multiple identities want to be only one at any given time, or want to claim only one identity at any given time. For example, when I came to the United States, I gave my mom, or I make my mom, a power of attorney, so she could represent me legally in my home country. Also, I have two brothers who also happen to live abroad, and they also make our mom their power of attorney. So at any given time, she can sign legal documents as each of us, and include as well as herself. So in this scenario, basically we have a principle that claims to be a sub-identity. This is the asserted principles. And now I'm going to go back to the architecture that Dan presented to explain to you how all these principles actually come to exist. So the bottom part is what you already saw, and I just want to highlight here that all those resources are in the customer space, but behind them, we have compute instances that are in the services space. So again, because the infrastructure is not about all these compute instances, we can define infrastructure principles that are all the ones on top and the three ones on the bottom, because the infrastructure can issue a certificate that defines them. So now, as you can see on the top, some of them got grayed out. So because having all these infrastructure principles, we can now define stacks principles that actually say this particular load balancer is actually this customer load balancer, and these three compute instances are actually this customer's database. So I'm going to explain the database case. So we map one of the infrastructure principles into stack principles, and now that as an identity, the database system can issue a signed request to send a file to the object storage system. And what are the advantages here? We are avoiding to grant extra authority to the database system, and also the user, from the user perspective, the user doesn't have to know anything about this. From the user perspective, he only just created a database and wrote some policy for it. And we're going to talk about policy a little bit later. Similarly, we can have a stack principle for the load balancer. And with that, the load balancer can request a certificate to present itself, and also to identify itself to the backend compute instances that distributes the traffic to. And now, look at the left to our testing scenario. When we use functions for testing, all these functions are customer written, and also they run for a particular period of time, in a container for a particular period of time, and then basically the infrastructure is decoupled from the hardware. So that's why we define ephemeral principle for it. And how do we do that? Similarly, we map the infrastructure principle into stack principle, and now a container having its own identity can make signed requests to the backend system. And now, on the right, going back to our multi-region backup scenario, we create a asserted principle for for that, because we know that we want to write a bucket into another region, but we don't necessarily want to do this as the object storage system. So we map one infrastructure principal into an asserted principal, and again, now, we can issue a request. The bucket in the region A can issue a request to write in the region B as the object storage, but it gets only authorized as the bucket in region B. And now I'm going to hand it to Dan to talk about the policy and close.
So how do we put this together? And again, this is a set of patterns, and you'll have your own. For us, we introduce a construct we call dynamic groups, which is a thing, it's a filter across all the principles. And so in this example of our syntax, we define that we want all of these attributes to be true, that the type of the resource should be a database. The tagging system we have has access control by namespace and by key. And so we say if it's got in the policy namespace with the backup key, a value of active, this is it. So this defines our group of all principles within my tenancy to say all my databases that I've marked as should be backed up are members of this group. And then I write a policy that allows me to say, allow all of these databases that have been marked for access to manage the objects with a couple of constraints, like it goes only to the right bucket, only in the right region, and it can only create them. And so the result is, going back to the example, the compute infrastructure at the top is a credential that rotates every 20 minutes with a new key set. It can use that to become a database. Any one of these three elements in the three-node rack that we've proposed here, any one of them can choose to make a request using a credential, again, that's been put in there by the infrastructure, and use that to call to the object storage system, and it will be authenticated as a member of this dynamic group. So to bring it out to what you should take away from this is by adding a bunch of more credentials, or a bunch of identities without adding new credentials, we end up with this way of very simplifying the model. I have my policy infrastructure just simply says the things I expect to be true. I expect my databases to be able to write to the object storage. I expect my load balancers to get my certs. And I don't have to worry about confused deputies. I don't have to worry about things being overpowered or not being able to understand them. I see a resource, I say what that resource can do. And again, now we can use this to compose on top of it. So if I'm building on top of the database, and it's actually a PaaS or a SaaS offering, I can say all of these things, the thing for my service, are this other resource. And now you, as the next level up, can use my service to say, I allow my whatever service to have access some other third service. And again, I don't have to know anything about how it's implemented, because I just think of it as, I went and purchased this thing, or I'm subscribing to this thing, I'm going to use this other one. So with that, thank you. Again, security. We don't care about this stuff. We're open to questions. Does anyone have questions? Cool. Well, I appreciate your time, everyone. Thank you.
Thank you.